First, let's say a big thank you to GroupBy for having me. It's an amazing conference, and I'm always happy to be here. I'm also happy to be assisted by the amazing Mala. She will keep an eye on the chat, on the Q&A window, I think there's also Slack and Twitter, so good luck with that, Mala. You'll have your work cut out for you. If there are any questions, just type them on any channel. She will interrupt me and I will try to answer them. Of course, we're a real conference, so we have a real harassment policy, or rather a do not harass policy. What's on the screen now is called the quick version. I have a quicker version. Wheaton's law, don't be a dick. That's essentially what this boils down to. Let's just all agree that this should not even be needed to be said out loud. But I was in this slide asked to include it, so I'm going to include it. Please restore my faith in humanity. Convince me that this was not needed. Any event needs sponsors, and GroupBy has an amazing group of sponsors, core sponsors, media sponsors, virtual group sponsors. We are a virtual event, so we don't have costs to host people. We don't have to hire a location, but there is definitely a cost with organizing everything. There is a cost with having a platform where everybody can watch using what is it? GoToMeeting, I think. I forgot what platform it is, but none of those platforms are free. So all these sponsors are very important. And if you meet people from these companies, just say, Jay, just tell them thanks for making GroupBy possible. Please keep up the good work. My name is Hugo Kornelis, and I make SQLServerFast.com. SQLServerFast.com is a website where I'm mostly dedicated to execution plans. I love execution plans. Execution plans are amazing. They are fantastic. They provide so much insight in the issues with performance. I will show a few execution plans now, even though they're not the main focus, but just to illustrate things, looking at an execution plan is always amazing. The only thing that's not amazing about execution plans is the documentation that Microsoft provides. I would love to say that the documentation is bad, but I can't because it's not there. There is simply no documentation about execution plans. You're on your own. So a few years ago, I started building the execution plan reference, which is starting to become, it's still growing. I'm not there yet, but I try to collect everything you ever want to know about execution plans there as a reference. And as a reference, it's not easy accessible. It's not a learning tool. So I've also started to record a set of training videos, the execution plan video training, a huge amount of videos, lots of material there, starting at the basic level until a very deep level. Some of it is available for free. Some of it I have to charge some money. But because I always love it when people watch me talk, I like to give you guys and girls and whatever. I need to stop saying guys. It's so in my system. I need to give you people, you friends that I all love. I want to give you a discount. So all of you, if you buy access to my videos before June 15 and use the code GRPBY21, and I believe capitalization is relevant, you get a 10% discount. So use it or not if you don't want to, but I think it's a great offer. Anyway, I have other content on SQLServerFast.com as well. I have my blog there. I have an area for longer articles. There's just one longer article now, but who knows, perhaps in the future. And very important, I have an area called resources. And if you go there, you can go to menu choice, other presentations, and then presentation resources. And then you can scroll down until you find the name of this session. And you can just download a zip file with the slide deck and all the demo code I'm going to show in the next hour. You can also download slide decks and demo code of all my other presentations. But of course, the one I'm going to talk about now will hopefully be most relevant if you want to experiment with the things I've talked about a bit more. So I do other stuff as well. I work in a community. I do a lot of stuff for the community. I also work for money, consulting, training, whatever. None of that is really what you're here for. You don't care about me, but you do care about my contact information. So if you have a question now during the session, as mentioned, a chat window, a Q&A window, Twitter and Slack. You can use them all. Mala has her work cut out for her. She will tell me your questions. But if you have a question later, you need time to let it sink in. And later you are like, yeah, there was this one thing that I really didn't get. Mail me, tweet me, I will get back to you. If you mail me and you don't have a response within a few days, it's not me deliberately ignoring you, it's me being sloppy or swamped. So just send me another mail, say, hey, I sent you a mail, did you forget? And I'll probably reply with, yes, I forgot, my apologies. And then I'll answer your question. So the contact information is there for a reason, use it. Okay, enough introduction. Let's talk about user-defined functions. And we'll start with, what is a user-defined function anyway? What are we talking about? After that, let's jump into demos, because who likes slides, right? Nobody likes slides. We want demos. So I'm going to show a demo. And after the demo is done, I'm going to show another demo. And then we'll have to jump back in the slides for the conclusion. And well, you can hold your questions until the end, but I actually always encourage people to just ask your questions as they come up. So what is a user-defined function? And it sucks that this is not a live conference, because in a live conference, this is where I like to get interactive and talk to people in the room and chat with them about what is a user-defined function. But I'll just give you my answer. A user-defined function is this: a black box. That's all it is. Not really, but it is important to keep in mind that in many situations, a user-defined function behaves like a black box. That has good sides and it has bad sides. So from a developer point of view, a user-defined function as a black box is awesome. You have some complex logic. You are probably going to need it in multiple areas in your system. Instead of copying and pasting that logic all over the place, you're going to build it once. You're going to test the heck out of it. Then you're going to close the lid. It's a black box now. Nobody cares how it works. We care that it works. Developers like to use this, call this a contract. Here's something you can call. If you feed it this data, you will get that result. Guaranteed. We tested it. You can depend on it. You can rely on it. But from a performance perspective, that same property of being a black box gets in our way. And that will become more clear as we work through the demos. So let's jump into a demo. Let's set up a sample scenario. You are a database developer for AdventureWorks Cycling Company. Now at this time, I always stop for a second, because when I'm in a room, there's some chuckles here and there. And that's how I recognize the people who have done certification exams from Microsoft. I never understood it, but for one or another reason, every question on a Microsoft certification exam always starts with, you are a job function for company. Most of the time, AdventureWorks Cycling Company. I don't care what your job is. I don't care who you work for. You have a job. You have a task. That's all that matters. But Microsoft insists on putting this in every question. So, hey, this is a Microsoft conference. You are a database developer for AdventureWorks Cycling Company. Microsoft is happy. Anyway, I have a job. I'm sitting at my desk. Yes, this is a pre-COVID example. Hear me out. I'm sitting at my desk. I'm busy watching working hard to optimize all the queries. Obviously, nothing else. I'm always very seriously working. And then out of the corner of my eye, I see my manager approaching. So I quickly alt tab into management. I quickly remain in management studio. And I ask her, hey, what's up? Well, Hugo, it's that time of year again. The boardroom is starting to talk about the changes in compensation for next year. And they have some pretty wild plans. Sales are low. The sales representatives are not working hard enough. They want to change that. They want to incentivize sales representatives to work harder. So their commission will go up by 25% and their base salary will go down by 25%. We expect that will drive sales up by at least 50%. So let's assume 50% for now. Then the hourly employees, we think just giving in to the demands of the union. The union is really strong this year. So we think just give them 3%, but the salaried employees will just remain as is. That's the thinking right now. Based on our historical average of 1,800 hours worked per year for every full-time staff member, we need a prediction of how this will affect our total salary cost for next year. Can you write a query to give us that? Yeah, sure, I can write a query. Remember, it's on the screen, right? I'm a database developer. I can write queries. So yeah, sure, I will write you that query. Give me a time, I will be at your desk when I'm ready. Okay, let's jump into the demo. Like I said, many demos today. I have already executed the prepare database script. And again, if you go to the resources on my website, you will not only find the slide deck, but also all the demo code. So you have all this code available to you. I've already run the prepare database script, which uses the AdventureWorks sample database to set up a new sample database called UDF demo. And in that sample database, I'm just going to scroll down real quickly. It's a few tables. It's the same schema as the AdventureWorks. But if you look at the data, I'll just remove the results. You will see that it copies AdventureWorks 100 times. So it's a really large version of AdventureWorks. In fact, at the end, I have count stars from all the tables. And let's restore the results. So you can see that we have almost 60,000 rows in the person table. 29,000 of them are employees. And then we have 1,700 salespersons here down. And we also have the numbers of rows from employee pay history and employee department history. So that's the sample data we're going to work with. So why this amount of data? Because we're going to talk about performance. And on my laptop, slower databases are always fast. So let's first pretend that I'm a bad developer. I do not care about code reuse. I make mistakes. I am a beginner. Okay, bear with me. I'm not really a bad developer. I'm actually quite good. Thanks for the compliment. But let's pretend I'm doing this the wrong way. So I start to think about the problem and I come up with a query. And let's talk you through a few main points in this query so you have a better understanding of what I'm doing. So obviously I'm grabbing data from the employee table because we want to talk about our employees. To help me understand whether the data is correct during my debugging and building, I like to add the name of the people so I can quickly do a match on the data in my test database, of course, to see whether the data that comes out is correct. So I take a few samples from my test database and I use my pocket calculator to compare it with the results of the query. So I have to join to the person table to get that data. That's okay. Now here, this case expression, I'll highlight the entire, whoops, that was the wrong highlight. I'll highlight the entire expression. This case expression is a bit complex. I'll skip it for a bit. I'll first go into the rest of the joins. So I join employee to person as mentioned, but then I also join to something called employee pay ranked, which is defined here as a CTE. The reason I do this is because in the employee pay history table, there can be multiple rows for a person. Now, something I need to point out, in AdventureWorks, I didn't invent the schema, I just copied it. They use a column called business entity ID as the primary key for the employee in the person table. So you can think of it as employee ID or person ID, but AdventureWorks calls it business entity ID because of Microsoft, I assume. So in the employee pay history for each employee, we can have more than one row if they ever had a change in their pay rate. Then a new row is added with a new rate change date, but the old row is still there. And the only way to know which is the current pay rate is to use the most recent one. So that's what I do here. I assign a rank based on an ordering by descending rate change date. Then I join with a filter on rank is 1. So I only get the most recent and I discard older rates for that employee. The last join is to the salesperson table, and this is a left outer join. Obviously, because not every employee is a salesperson. We want all the employees, but for salespersons, we want additional data. Now, a left join obviously gives me null values if there is no matching row. And I use that here. Business entity ID is the primary key of the salesperson table as well. Obviously, that can never be null, except when the left join produced no row. So here I check if the business entity is not null, then we actually had a match here, and we know that we're working on an employee who is a salesperson. So for this employee, we use the formula as defined by management and given to me by my manager. We cut their rate by 25%. We increase their commission by 25%. We assume their sales will go up by 50%. And we multiply that by the 1800 hours they work. But, well, not everything. The rate is multiplied by 1800. The commission is multiplied by the sales. So this is the formula for the new total wage for salespersons. When you're not a salesperson, you come to the next when. That's how a case works. You have multiple whens, you just trickle down. So the non-salespersons are now tested for, are they salaried? If yes, remember, salaried people do not get a change. People on hourly rate get a 3% increase. So there's all that logic in this case expression, and the result is their new salary. Wait, let's first make sure we're in the right database. Otherwise, we'll only get errors. And now I will execute this query. And because I love performance, I always check performance of everything I do. So I already enabled execution plan. Now the results are there pretty fast. And I will not bore you with checking the results. I did that before. This is correct. So you won't see me typing in on a pocket calculator right now. Just assume I did. I have enabled set statistics IO so I can see how much work was being done. The scan count 9 may look scary, but that's because the query went parallel. We will see that in the execution plan later. But the logical reads is where you really want to look at. So let's zoom in a bit, and then you see all these numbers, and all these numbers are, well, some of them may appear high to you, but they are actually the numbers of rows of pages that are in each table. So every table is read exactly once. And with a query that doesn't have any where clause, it's logical that the tables are read entirely. So that's okay. In fact, when I look at the execution plan, I can see from the parallelism icons that the query ran in parallel. I can see that scans are being used, that merge joins are being used, and all of that makes my tuning heart happy. This is a well-behaving query. So after checking that performance is okay, after checking that the result, sorry, wrong order. After checking that results are okay, then after checking that performance is also okay, I went to my manager and told her, hey, I have the results you asked for. Here's the data. And I saw her face go pale. Hey, Hugo, you may be presenting to an American audience in an American timeline now, but you're still in Europe. We have GDPR here. What the heck do you think you're doing? Putting names in there. Are you an idiot? Stupid, stupid, stupid. It was safe to do that on my development system because there's fake names. This is production. I can't do that. So very quickly, hastily, I comment out the line where I added the name, and I quickly re-execute the query. Whew. Bullet dodged. I hope my manager won't talk on me. I hope it's okay. So here's the data. Now, before going into the response of my manager, I want to point out something interesting that happened with performance when I did this. And I know I'm already 15 minutes in. I know we're not talking about user-defined functions yet. Bear with me, we'll get there. This is important foundation. So I want to point something interesting out. When I now look at the messages, you will see that the person table has gone. The person table is not being read anymore. I will highlight the query once more. In my rush to remove this, I did not remove the join to the person table. I tell SQL Server join to the person table. SQL Server doesn't access the person table, and if you look at the execution plan, I'm not going to go through it entirely, but trust me, the person table is not accessed. The optimizer looks at my query, says, oh, you want to join to the person table, but you're not using the data. and I have a foreign key relationship. I have a uniqueness constraint. I know it's an exact one-on-one relationship. I will never remove rows from that join. I will never add rows from that join. I'm not going to grab additional data from that join. I'm just going to skip the join altogether because it won't affect the results in any way. And that's how SQL Server, even though I was incredibly sloppy by leaving this in, SQL Server still gives me the performance improvement made possible by removing this join. Anyway, my boss doesn't care about that. My manager cares about the data. So she's happy that I have the data, but then she says, hey, Hugo, minor detail. That's 29,000 rows. Do you expect me to print that and dump it in the boardroom and give them a few pocket calculators to add it all up? I want a total. You idiot. She calls me an idiot a lot. I don't know why. Anyway, it's probably her problem, not a me problem, obviously. Anyway, she's right. I need to give a total. But it's a good thing that I have this query because I have checked this on the individual person level. I know that for individual persons it's okay. So I copy the query. I type sum around the complex formula. I remove the detail columns. And obviously, now that I have more time, I actually removed the join to the person table. And here I have just the total of everything. And this is the number my manager needs. And again, performance is good. A single scan of every table, merge joins, scans. I'm really happy with this. So my work is done, at least this part of my work. So I go back to watching tuning other queries. Until slightly later, I hear muffled sounds coming from the boardroom. And the walls are thick there. It's well isolated. So if you hear sounds coming when you're outside, something's wrong. And indeed, a few seconds later, my manager approaches again. Hey, Hugo, probably shouldn't tell you, but the blame game has started. They want to know who is responsible. Can you break this down by department for them? Sure, I can do that. So what do? I copy the same query again, still with the sum, but now I add the department ID column. Now the department ID was not in any of the tables I joined to, so I had to join to a new table, the employee department history. Like the pay history, this is a table that the rows get added to when employees get reassigned. But here I don't have to use the trick with the CPE I had to use before, because in the employee department history, whoever designed this had the good idea to add an end date that they could fill when someone went to another department. So now I can just filter on end date is null, and that is the department every employee is working for. So here I have my new query. Yes, I selected it completely, executed, and this is the data my manager wanted. Again, with an execution, okay, there's hash matches now because the order is different, but mostly the same good performance with just the scans and no access, not too much data access. I'm happy with this. But while as I give this to my manager, she tells me, hey, before you return to your video watching, what, me? Before you return to your video watching, I have one more task for you, because we want to put something on the intranet so that once this is decided and final, keep it under covers for now, but once this is decided and final, we want everyone to be able to log into the intranet, and then they can see what they can expect to be the result for them next year. We already talked to the web guys, they're building the front end, and you trained them well. They want you to build the store procedure they can call, because they know you will have their ass if they do it any other way. So build that store procedure for us, please. Now, this is where performance really starts to get important. I mean, there's 30,000 employees. They will all hit that intranet server at the same time. So there will be a high load when this releases, when this internal email is sent. I need to make sure that this query is on top. So I once more take the same query I had before, the one where I was at the individual staff member level. and I add a where clause to filter it down to one specific employee. This will eventually go into the body of a stored procedure, but for testing purposes, I just run it as a single query with a variable. And when I run this, I get the correct results back, of course. And I look at the performance and I see, okay, 2 logical reads, 3 logical reads, here's 151 logical reads. That's not a big problem, but it could become an issue. I look at the execution plan and I see nested loops and index seeks, which for this kind of query with a selective clause is very good. I also see one branch that starts with a scan. That's the only thing I'm worried about. So I do some rewriting, and instead of using this CTE here, I now use an apply with a select top one. Now, if I would do this in the original query, performance is terrible. I don't have it in my demo, but trust me, you can try it yourself. If you do this in any of the other queries, you will get terrible performance. But for this specific version of the query, for just a single person, it's actually good, because now the execution plan shows only seeks and nested loops joins, and you will see that only 2, 4, 7, 10 logical reads total are needed across the 4 tables to give us the data we need. So I'm happy. And at the end of the day, I'm done. The next day I return to my office and my manager is already waiting for me. And she says, yeah, they made some changes. The 3%, they'll cut that down to 2%. And no change at all for the hourly employees. That's not going to go there. They'll give them a 0.5% as a token. And you know what? That 25% cut for, well, you get it. All the numbers change. Now here's my problem. Remember, this was me being a bad developer. I have copied and pasted this query 1, 2, 3, 4, 5 times total. So now I have to change all 5 copies. And if I change all those 5 copies, how easy is it to make a typo? To do a 1.15 here instead of here, if that should have been the case? These were only number changes. What if my manager told me, yeah, this idea of 50% increase in sales, that's realistic for America. But in South America with Brazil and COVID, we'll be happy if they can remain stable with their sales. And in the Pacific, we have just started, so 50% is free there. They should get at least a 200% increase. So now I have to somehow find the region where a sales manager is working, which probably requires an extra join. And that extra join doesn't only go here, it also goes here, and here, and here. You see the problem. So this is why I was a bad developer. Let's erase the past half hour. Yes, I just wasted a half hour of your life. Let's go back to when I first was watching my cat videos, working, and when my manager first came to me with those requests. And I immediately realized, oh, this is going to be a lot of copies of the query and they will change tomorrow. So let's do something reusable. In books online on TechNet or MSDN or wherever I look, I search for something and I find something called a user-defined function. It's a great tool. You can just declare it, you give it a name, you put in some parameters, and then it returns something, money in this case, and you compute it inside. So for the projected commission, I just say, okay, I want to know the business entity, the person ID of the salesperson, and then I grab their current commission percentage and their current sales YTD and use that plus the past in values here to compute their expected commission for next year. Let's just go ahead and create that user-defined function. And then on top of that, I build a second user-defined function, get projected wage, where I pass in any employee and a lot of other stuff. We'll get that later. So I do a simple exists to check whether this person is a salesperson or not, and I just set a variable to track that. Then if they're not a salesperson, I care about performance. For salesperson, this doesn't matter. So only if they are a salesperson do I query the employee table to check whether they are salaried or hourly. Then, very simple now, for the single employee, I get their most recent pay rate. And then I can just use if and else for all the three cases with all the formulas. And in one of those formulas, I simply invoke the user-defined function we already declared before. Simple, right? So create this user-defined function. And now with all the groundwork done, the rest actually becomes very easy. So this is all I now need to do for my test work. So for my test work, where on my development database, I still check with the person data. I can still just grab this data and I just use the user-defined function here with the number of hours, the percentages for sales, for the base salary of salespersons, this percentage for the hourly, and all those other percentages just as an argument passed in. And I can just run this. And you see the results are there, it runs fast, it's perfect. And if I switch to the messages tab, you will see that it even had less data access than before. We read the person table, we read the employee table. We didn't even read the salesperson table. We didn't even read the employee pay rate table. That's awesome that SQL Server can do all this, giving the correct results without even reading the base. Wait, what? What did SQL Server do? Without reading the base data? I'll let you in on a secret. SQL Server is lying here. It's lying its ass off. Of course, it accesses the other data. It just doesn't tell you. Because why would it? Let's look at the execution plan. In the execution plan, you also see only a join between an employee table and a person table. And a very insuspicious looking compute scalar. Cost at 0% is the expected cost. It's not doing much here. We expect it to do just 0 IO and only 0.0028 CPU. Virtually nothing. What does this compute scalar do? It invokes the user-defined function. You can see that here. It invokes the user-defined function. Okay, cool. But nothing wrong, right? It was fast enough, so no issues. We obviously needed the total, remember? Well, same ID, just remove the details and execute it, and the result, wait, I thought it was instant. Where's my result? It took 4 seconds. Now 4 seconds is usually not a lot, but imagine doing this on a 1 billion row table, and then you're hopefully not talking about staff, but if you have 1 billion customers, you're happy until you see the performance of this kind of thing. So how does this take 4 seconds? It only did 92 logical reads. 92 logical reads can't ever be 4 seconds. The execution plan is as simple as it gets. How can this be 4 seconds? Again, SQL Server is lying to you. And you actually can see a bit more if you don't execute the query, but only request the execution plan. Now you see at the top the same execution plan. You see at the bottom another execution plan that is used for the get projected wage. So here we see the actions needed to execute get projected wage. These actions are executed in this case within the stream aggregate operator. The stream aggregate operator has to do this get projected wage for every row. So for every row it does this. We expect that a single execution of this costs 0.0098 cost units for a single execution. We expect that it is executed 29,000 times. 29,000 times 0.098, I think it was. So that's a total estimated cost of 0.174. In this case, SQL Server is even lying to itself. SQL Server knows the estimated cost of this user-defined function, but when computing with it in this plan, it actually assumes the cost is 0.000001, which is incredibly low. So low that if you look at how this average is computed, it has no issue with saying, hey, I have to count the numbers, so I have to execute it here, but I also have to sum them because I need an average. So let's just execute it a second time. So this user-defined function actually executes twice for each row because we asked an average. That's insane. You want to see how insane? Well, Now I'm going to skip that, but no, I'm not going to skip it. I'm just going to show it. I need to connect to the database first. And I have an extended event session. If Grant is in today, he will love me for doing this. And I will skip the UDF demo 1, but I will go to the UDF demo 2, which is quite heavy. You do not want this normally on a production server. But I'm going to start it. I'm going to watch the live data and I'm going to re-execute this. And now we will see what's happening. So again, this will take a few seconds. It might even be 5 or 6 now with this running. I get an error message from extended events because it can't keep up. There's so many events being generated, it can't keep track. So it cuts short. But if I look here, you will see how many stuff has been done. You will see over and over repeated again the same statements from that user-defined function. So that's all the extra work that SQL is doing, and that is not visible in the execution plan and not visible here in the set statistics IO. It's simply not visible, but it's there. The rest of the demo is quite okay. The other examples run, well, this example has the same issue as the one before. This one actually runs pretty fast because it's just for a single person. But as a whole, I'm not happy with this. And the biggest reason I'm not happy with this is, of course, this user-defined function doing data access. And again, if I look at only the execution plan, I can see that it does a seek here, another seek, and then if for the salespersons, it also does a seek here. So that's a lot of seek activity, and it does all of that for each person. Twice, in fact, because the optimizer is stupid. That's a lot of seeks. A seek is good, but not if you do it 100,000 times. So I should actually get the data access out of the user-defined function. I can do that. So I rewrote it using a user-defined function where instead of getting the person ID and then grabbing the current commission and current sales, I actually pass in everything as variables and I only do math here. So I can create a user-defined function like this, and that's okay. And I can create a second user-defined function for the wage, and I'm going to go, I mean, this is the same logic. It's the basic idea. I'm going to go a bit fast because I've been a bit too slow before and need to catch up. And now I can use this user-defined function to grab all the data. I need to pass in a lot of arguments. That's okay. Well, except, of course, I need to get those arguments from somewhere. So guess what? This ugly from inner join, left outer join, plus a CTE on top, all that complex logic is now back. Yes, this performs good. I mean, SQL Server is still not completely truthful about everything, but let's not get into the details. Most of it is pretty good. It's fast. It's really fast in this case. It's not just presenting the first rows fast and then taking more time. And all the other versions, the total for everything, it's fast. It's all okay. I'm not going to run all these demos, but it's just, this is good. Except, as you see, I have a lot of duplications of my code again. And if I need to add, for instance, that extra join to get the region where a salesperson is active, I need to add that join to all the copies of that query. So yes, I'm using a user-defined function, but I'm not getting the benefits. Okay, I don't get the downsides anymore either, but I also don't get the benefits. So we have a problem. If I do the user access within the user-defined function, then I don't see what's happening because remember, black box, we don't see what's happening. The optimizer gets confused because the black box is so black that even the optimizer has no clue what's happening inside the user-defined function. And it's all terrible performance. So let's go back to Books Online and look for another solution. And then I find that there's another type of user-defined function called a multi-statement user-defined table valued function. I don't know who came up with those names, but I'm sure they're paid by the letter. Some of the names from Microsoft are terrible. So this is a different type of user-defined function. You still pass in a lot of arguments, but you don't return a single value, you return a table. So I just create a user-defined function that well, you remember this query, right? With employee ranked and then all the joins. The only thing I did was adding an insert into to put it into a temporary table, which is this temporary table that will be returned at the end. So if I execute this, I create a user-defined function that does the same work as in the original example, all the way on the top, this big query does. But now it returns it as a user-defined table, a user-defined function table. Because it's a table user-defined function, it's used in the from clause. So this is where I call the user-defined function. The SQL Server pretends it's a table. Well, it returns a temporary table under the cover. And this is very simple. I can just run it. And if I execute this, it will be, oh, I forgot the execution plan. Let's do it again. It will be pretty fast. Well, we all know already this is a lie. We don't trust this anymore. That's okay. We're cool with that. We also know that this is not strictly a lie, but incomplete. Yes, we know it does a table valued function, which is a black box. We don't know what's going on inside. And after it does that, it reads data from a temporary structure, which has been filled here. Good. We can see a bit of what's going on inside by asking execution plan only, because then we see the same execution plan, but on top below that, we also see the execution plan for populating that temporary table in the user-defined function. And well, merge, joins, scans, we have seen that pattern before. So this is quite okay. However, now when I comment out the names, because GDPR, and execute it again, I cannot remove the person table because it's inside that black box. And if I execute it, you won't see it. But if you use an extended event session to track what's going on, or if you ask the execution plan only, then you will see that the user-defined function still accesses the person table here. The black box works both ways. When inside the black box executing that user-defined function, the code doesn't know what you're going to do with the data. It doesn't know that I am going to ignore all these columns. So it returns them. And that means it has to access data to produce them. So that's already a downside. What's worse is if you add the departments. Because now, and this is an area where SQL Server actually stops lying to me. If you look at the statistics.io, you see that the number of reads on the employee department history table, scan count is 29,000, and I have to zoom out and zoom back in to see the rest. The number of logical reads is 61,000. It's reading the entire table thousands of times. It's way more pages than there even are in that table. This is an insane performance issue. And if we had really large tables, it would be incredibly slow. Why is this? Well, we still have the same pattern of execute a table valued function to populate some data and then get that data and do something with it. But now it does more with it than just return it. And that means that for getting the execution plan, SQL Server cares about how many rows it thinks there will be. And that estimate is hard-coded at 100. That's simply how SQL Server works. It has no way to predict how many there will be. It has to put in a number there, so it puts in 100. And the real number was, the real number was slightly higher. It was 29,000. For 100 rows, a strategy with a nested loops and a clustered index seek makes sense. For 29,000 rows, it doesn't. For 100 rows, this sort needs a limited amount of memory. For 29,000 rows, that memory is no longer sufficient. So we get all kinds of issues because this user-defined function, this multi-statement table-valued user-defined function, is always estimated at 100 rows. Finally, let's think about what happens when the internal email goes out and 20,000 employees within 5 minutes all execute this query. They get their results. Sure. The table valued function is built and then a seek is used to get just a single row. Oh, seek, that's sufficient, right? However, let's look at execution plan only once more. In order to fill this data, remember, we have this black box when inside get all projected wages, the code doesn't know what you're going to do with it. So it's going to fill the data. Well, the estimate is 33,000. I know that in reality, it's going to fill the data with the table with 29,000 rows. So assuming 20,000 of our employees hit the server within 5 minutes, that means that within 5 minutes, there will be 20,000 executions of a query that fills a temporary table with 29,000 rows and then uses an efficient seek to get one of them. The only thing efficient here is the seek, the rest is terrible. I do not want this on my server. It might crash my server. And there's no way I can fix this. So this is not a good solution either. And I'm about to give up, but I don't like to give up. So I keep searching. And then I realized there's one more type of user-defined function. It's called an inline table valued user-defined function. And the inline table valued user-defined function has the same syntax as we're going to create a function. It says it returns a table, but it doesn't specify how the table looks. Instead, the entire content of the function can only be a single return statement followed by a table expression. So now we have the problem that we need to find a way to define this entire table. I'll make this font slightly smaller so we can actually see it all on screen at once. Should have done that before. So that we can have, we need to have the entire logic in a single query. Well, luckily in this case, remember the first demo, I already have everything in a single query. So I can just copy paste that single query. In real life, you will often have complex logic that uses multiple statements, and then rewriting it into a single query can be a challenge, but it may be worth it. So let's create this inline user-defined function. And again, it returns a table. So we use the same syntax to call it. But now let's look what happens. I execute it in my development environment. So with the names there, I look at the messages and I get all the information again. Everything is there. I see how many reads there are. I get the execution plan and it shows me everything that's going on. I see the scans, I see the merge join, I see the parallelism, I see everything. The optimizer can also use all this. So when I comment out this single name, the single line, I cannot remove the persons table from the user-defined function. But SQL Server can still remove it from the execution plan. There's no person table here. There's no IO on the person table. I like to see this as a black box with a glass lid. We still have the black box that has all the logic in a single unit that we can safely reuse. But there's a glass lid for the optimizer to peek in and actually do smart optimizations. This is like the best of both worlds. And if you run all the other demos, you will see in all cases that you get the ideal case. Well, the only one is for the web farm where we do 20,000 executions of this. Now I have this single pattern back where we have a clustered index scan here that results in 151 logical reads. I mentioned before, it's not the ideal case, but it's acceptable. Here I cannot rewrite it because I cannot rewrite the code for this single case only without affecting all the other cases. And I mentioned before, the rewrite is terrible for the other cases. But this is the trade-off I will take. So finally,
Hugo, you have a question?
Yeah, I'll finish the sentence and then I'll ask the question. So finally, I have found a way to have the best of both worlds. And it's actually the end of this demo. So it's a perfectly timed question, except you were 20 seconds too early. What's the question?
Sorry, person wants to know, do inline table valued functions support hash and hash tables?
Yeah. Yes, you're talking about memory optimized tables, and there is no limitations as for us. You can simply use memory optimized tables in there. I don't think that inline user-defined functions can be natively compiled, but if you use interrupt for your memory optimized tables, you can just use those memory optimized tables in user-defined functions without limitations.
Okay.
I think the question is temp and global temp tables, if it's hash and hash. Sorry.
That's what I thought. I wasn't too sure, but he was saying a memory optimized tables. But yeah.
Inline table valued functions cannot use temporary tables. I'm not sure about global temporary tables. I've never tried that, and frankly, I don't like using global temporary tables.
I didn't know
I have
anybody who
in
used them
my
too.
20-year
Yeah,
career, I have had one use case where I had to use them because limitations and reasons, and that was very specific case. Generally, global temporary tables are a bad idea. If you need that, just create a table in a user database and manage it yourself.
right.
Normal temporary tables are great, but you cannot use them in user-defined functions. I've never tried with global temporary tables. If you put a gun to my head and say, do a prediction, I say probably not. I think that gives me the best chance of survival. So I promised more demos, right? So if there's no more questions, let's jump into the next demo. A scenario, you are a database developer for, you know what, never mind. You have a job. And in this job, you are faced with a weird database structure where there's multiple lookup tables for countries, for states, for areas, for regions, but there's all considered locations. And other tables, fact tables, can refer to those locations in a weird way. Not necessarily a smart way. I'm not going to present this as a best practice for how to solve this design problem, because I don't think it's a smart way, but we inherited the code, okay? Plus I needed it for the demo, and I was young and I needed the money, and more of those excuses. So the explanation is a bit sketchy, but as I run the code to create the sample database, I'll show you what I mean. So on the screen, you see a table called continents with a continent ID and a continent name, standard normal lookup table. And I have some sample data there. Continent 1 is Africa, continent 2 is Asia, and so on. Then I also have a table of countries, and for the demo, I just put in 6 countries. There is, of course, many more countries in the world, and don't feel left out if your country isn't there. I just put in a random, okay, maybe not totally random. I put in a sort of random selection. We also have a similar table of states. Now, what did my voice do there? We also have a similar table of states. And then we have something that's more specific to the company. They work with areas, and an area is just a larger part of the world, like the Americas or the EMEA region or the entire Pacific. So they have that table. And then they also work with regions, which are sort of in between countries and continents, like, for instance, the European Union, the Greater China region, and the USA has probably been divided in Northwest, Southwest, Center, Northeast, Southeast, whatever. I think that's fairly common for USA. So we have all those kinds of tables. And now when we track sales, if you do a sale in the Netherlands, that's in the Netherlands. The Netherlands doesn't have states, so we track it as in the country, Netherlands. I think it was 3. But if we make a sale in America, we want to know more specific than just USA. We want to know it was in the state of Kentucky or in the state of Delaware or whatever other state. So we can put in a state or a country here, but we can't use the rest. So we have a check constraint that says the location type has to be C or S. And then based on that location type, we need to know how to interpret the location ID. Cool. Sample data, Denmark, country 1. And in a sale in America is tracked as state number 1, which happens to be Washington. For sales representatives, we also have a table, but there's more flexibility. So we have a sales representative who works in the entire Northwest. That's region 3. A more specialized sales representative might work in only the state of Kentucky. We might have one responsible for the entire Pacific area or for just a country. So all those are valid. Country, state, area, and region are valid. Continent is not. No sales representatives ever get a full continent. However, directors are responsible for continents. Yeah, and I know the O for continent. I didn't design English. Remember, country, continent, both with a C. Whoever came up with that should be punished. It's not my fault. So continent is with an O. But Directors are responsible for areas, regions, or contents, but nothing smaller than that. So here we have a check that says A, R, and O, and again, some sample data. Now, I also wanted a performance test, so I also created a bigger table with the random data. So I created a big table where all the location types are allowed, and I actually use a random number generator to give random codes from CSARO and a random number of 1 to 6 for each. That's why I have 6 countries, 6 states, and yeah, I had to add some fake areas and region to have 6 in every table. I created all the data, and now I can start working. Now, I know I'm not going to use a scalar user-defined function. They are bad. SQL Server lies to us. Their performance is bad. But I am going to go through a sample user-defined function to show the problem area. So I need to get a faster, more performant way to do what I'm doing here on my screen. Because what I often want in those tables is to just get the name of a location. Remember, in the tables, we have state 6. Well, nobody wants to see that on their screen. They want to see Kentucky on their screen. So I need to be able to pass in the S and the number 6 and then get Kentucky back. That's what this user-defined function does. So it simply looks at the location type. Is it a C? No. Is it an S? Yes. Okay, grab the state name of the state with location ID 6 and the rest is skipped. For every location type, it does one of those lookups. And yeah, this works. This gives me the data I want. So I can do this and I can look at the statistics and I can look at the execution plan if I enabled it. It's not really irrelevant because SQL Server will be lying again. SQL Server will again not show what's actually going on. So I'm not going to use this, but I now have defined the problem area. I need a user-defined function that gets C1 as input and gives us Denmark. Now I already know I want to use an inline table valued function. So that means I need one single query. That was the right demo. So this is a bit of an odd query, but it works. So let's first make sure we're in the right database. So what I do in this query, and I'm using the big table because that has the most extensive table for this example, I grab rows from the big table, and then I do an outer join to, for instance, the countries table. But in this outer join, I have a check on something that is not even in the countries table, that is in the big table. So an outer join, this outer join based on this join condition can never produce a row for a state row in the big table because the state row has an S here and not a C. So this row will never produce anything for a state. This join might produce a row for a state if it's a valid state. If it's not a valid state, we have bad data. Let's assume we don't have that. And then for a state, the other joins will all produce nothing. So for a state, we only get a row here. For a region, we only get a row here and not from the rest. So for every type of location, one of these 5 names will have a value and the others will be null. And we then use coalesce to find the correct name. And yes, this works. This gives us the correct data. And I once more forgot the execution plan. But if you look at the execution plan, you see hash matches, which is okay in this case. You see clustered index scans. And everything is just 25 logical reads on the big table. That's how much data is there. 2 logical reads on the rest. Cool. I'm happy. Now, if I do the same on the countries table, I can just copy and paste this query and just change this table name. I didn't even change the alias. I just changed big table to sales, left the rest unchanged. And yeah, I know there's too much joins in there because we don't have areas and regions in the sales table, but SQL Server is smart. SQL Server will figure out, hey, I only need the sales table, the countries table, and the states table, and not the rest. There's also no IO on the rest. SQL Server knows this because this location type in the sales table has a check constraint. SQL Server knows this cannot possibly happen, so this join is not needed and it will leave it out. Now, in case you looked at the execution plan and thought, hey, there's nested loops and seeks, oh, no seeks, but there's nested loops, that's not ideal for this type of query. That's correct, but I only put in 2 sample rows, and with 2 sample rows, this is correct. If I increase the number of rows in the sales table, the execution plan will change. Anyway, I can do the same for the rest, but I want it in an inline user-defined function. So here is a copy of this query on the big table in a user-defined function, an inline user-defined function, the type we have learned to love. And I can now grab data from this user-defined function. And again, because it's an inline user-defined function, even though the query only accesses the user-defined function, we see everything that's going on under the covers. We see all the joins and the scans, and we can get all the statistics I/O. But now I want to do this on the sales table, and now I have a problem because for the sales table, I need to change this. And table names cannot be variables in user-defined functions. So I cannot pass in a variable as the table name. So what I have to do is create a new user-defined function where I put in the sales. Yeah, that works. But now I have user-defined functions for the big table. I have one for sales. I have one for sales representatives. I have one for directors. I'm not reusing code. I am hiding my code reuse better, but I'm not reusing my code at all. I'm still creating multiple copies of it. So again, we're hitting a brick wall. And then that's when I realized, hey, SQL Server has been lying to me all the time, right? So why not return the favor and lie back? So here's what I'm going to do. I'm going to tell SQL Server, I'm going to create a user-defined function. And I use the syntax for an inline table value function. So yeah, I'm going to return a table, really. But there's only a single column in that table. Do you mind if it's a single column table? No, single column table is still a table. Okay, and then the query, what I use here is a table value constructor. So from the parameters passed in, I create a virtual table called I with 2 columns. Now, because these are variables, this is by definition a one-row table. And then I use the same left join trick I showed before to join to the rest, but it's going to stay a one-row table. So what I'm actually returning here in this inline table valued function is a table of 1 column and 1 row. That sounds like a scalar function to me. But shh, don't tell SQL Server. We'll tell SQL Server this is a table. And only me and the few people who are watching this know that it's actually just a single scalar value. Okay, keep it a secret, right? Agreement. Let's create this. And now, first a quick test. Let's see if country number 1, and yeah, I need to pretend it's a table, but I do a select star. So I get everything back from this table, everything, a single value, but again, don't tell SQL Server. It's our secret. And this works. I can put any code location type in there. I can put any location ID in there, and I will get the name of that location back. So we have something that works. But it is not a scalar user-defined function. We have to keep pretending it's a table. So we have to put it in the from clause. So if I want to join it to the sales table, I would like to do something like this. But you may see the wigglies there and the error message when I hover my mouse. Let's try anyway. Maybe SQL Server falls. No. You see, there's this issue that in a from clause, everything has to be independent. There is no official order. So this could be evaluated before joining to sales. SQL Server should be free to switch the order. And that means that it's simply not allowed to have an expression here that uses something from another component of the from clause. This is invalid syntax. SQL Server has found a way around it by using a different keyword. So this is a keyword that's not in the ANSI standard, but SQL Server supports it. And this is basically the same idea as a cross join, but now we can refer to this. So this means that on a logical level, on a conceptual level, for every row from sales, this expression gets re-evaluated. The optimizer can do smarter things than that, but that's the logical definition. And then we join to the table coming from that. And if I do this for the sales table, then we will get our results back. And oh, I forgot the statistics I/O, I think. Oh, no, that's here. So it works. We get the correct results. That's all I wanted to show now. So let's look at the performance. Let's do the performance on that same sales table. Execution plan is enabled. And if I look at the messages, I see that states, countries, and sales have been read, and the rest of the tables have not been read. So we again get this benefit of the optimizer eliminating tables that are not used. The method for use for that is more complex now. The execution plan is actually bigger. There's a lot of stuff going on here. At least it seems to be. But as you see, a table like areas is still there. But if you look at the properties, you will see that the number of executions is 0. It didn't actually run. That's because there's a filter here that doesn't filter rows it receives, it filters on start. So this filters only executes its child if the location type is A. So this is a different way to achieve the same thing of not processing tables we don't need. And this works for all the other examples. And yes, for the big table, the performance is slightly worse than when we didn't use the user-defined function. As you see, the number of logical reads is slightly up. But other than that small difference, we still have all the benefits of code reuse, but in this case, only a very small performance benefit for one case and no performance issue for the rest. So still, I say worth. So let's recapture. I know I'm 5 minutes over time, but I also know that the next speaker isn't up until 9 my time. So I'll just take my time. Scalar user-defined functions, most of the time, just don't use them. When they're in a query, they will be invoked once for each row, sometimes even twice for a row, as we saw in the demo. If it's a user-defined function with data access, the data will be accessed for each execution individually. The optimizer cannot combine stuff and realize, hey, we're doing this for all the data, so I can better do a scan. No, it has to do it for each individual execution. Also, I didn't mention this when going through the demos, but as soon as you have a scalar user-defined function anywhere in your execution plan, anywhere in your query, then that query can only run in serial. It cannot use parallelism anymore. In SQL Server 2019, there is an improvement to this. It's called scalar user-defined function inlining. It's an interesting topic to talk about. I don't have time for it now. After it released, some serious bugs were discovered. They may be edge cases, they may not hurt you, and I'm not saying you should never use it, but they were serious enough for Microsoft to say, let's just disable this in Azure SQL database across the board until we have the issues figured out. I still say in your database, if you test and verify, you can use them. Most of the time, scalar user-defined function inlining gives you great performance improvement. In a few cases, it will hurt your performance. And in some very weird edge cases, it might give you incorrect results. So do test. If the results are correct and your performance is better and you're on SQL Server 2019, then scalar user-defined functions lose some of their issues. Not all. Multi-statement table valued I cannot pronounce that. Multi-statement table valued user-defined functions also kill performance. They have to be completely evaluated before the rest of the plan is executed. And remember, no glass lid black box. All the results are stored in a temporary table without optimization with what's going to use it, because then the rest of the plan only looks at the results and says, oh, I don't need everything. I'm just going to pick what I need. I showed the fixed cardinality of 100, the fixed estimated cardinality of 100 rows. That's actually valid since SQL Server 2014. Up to SQL Server 2012, the fixed number was 1, which was even worse. Starting with SQL Server 2017, there is a new feature called interleaved execution, which in some specific edge cases helps. Most of the normal use cases of multi-statement table valued user-defined functions are not affected by interleaved execution. It only fixes a few of the issues. Unfortunately, my demo happened to be one of the few cases that was fixed, which is why I have to present on the SQL Server 2016 instance, because my demo actually fails, as in suddenly we have good performance on a SQL Server 2017 or newer instance. But a lot of real use cases of multi-statement table valued user-defined functions, I hope that's the last time I need to say it, a lot of the real practical use cases out there are not affected by interleaved execution. Finally, inline table valued user-defined functions. they are okay. They actually work similar to a view, but then with parameters. I would have loved if Microsoft had called them parameterized views, because I think that covers the issue better. What happens is that the definition is substituted in the query in place of the name before it's fed to the optimizer. So the optimizer doesn't even see a user-defined function. The optimizer just sees complex code where the original code of the user-defined function is injected into the query. Often you cannot
So
use
Hugo,
join.
you have 20 minutes to go. You're not.
I know, but I'm almost done. I know. I plan to give everyone at least a 15-minute bio break, but
Okay.
or we can do 20 minutes of questions. But I'm going to finish my conclusion first, and then we'll jump to the questions. So you may need to use apply instead of join. If you've never used apply, read up on it. There's cross apply that I showed in the demo. There's also auto apply, which works like an auto join. It's a cool feature to know, even if you don't use inline table valued user-defined functions. As you saw in one of the examples, you still are bereft of some control. You cannot do different versions of the query for different cases. You have to have one case of the query that's used in all cases. The biggest problem with an inline table valued user-defined function is that you may have to convert your existing code. If you're currently using a multi-statement table valued user-defined function, and you want to convert it to an inline table valued function, and after this demo, I really hope you want to do that. The issue is that you will have to look at the existing code, which can be multiple statements, and then write a single query that does the same thing. And yes, that can be complex. That can be a challenge. And in some cases, that single query becomes so complex that it causes its own new performance issues. So even this is not a silver bullet for all cases. If you currently have a scalar user-defined function and you want to use an inline table valued user-defined function, then also you have to rewrite it as a table expression. But also everywhere it's called, you have to change it, because a scalar user-defined function can be used in the select or in the where or in the order by. But an inline table valued function has to be in the from, and then you can use the columns from it in the rest of your query. This is a one-time effort, but you will have to rewrite all the code that uses the original scalar function to instead use the inline function. After this one-time effort, you are back to a black box that can be maintained independently and doesn't require all code to be changed, with the benefit of the glass lid for performance reasons. So moving to an inline table valued user-defined functions is a challenge if you currently use any of the other types of functions, but the benefits are worth it. Are there any questions, Mala?
I cannot see anything. And you did great. You did fantastic. I particularly really enjoyed that part about fooling SQL Server into thinking it's a table. That was priceless. That was awesome.
Yeah, SQL Server is lying so often to us. I thought, let's for once return the favor. So if you have questions later, mail me, tweet me. Once more, thanks to the sponsors for making this amazing event possible. And that's all I have, unless any new questions have come in. And otherwise, you have now 17 minutes for your bio break.
Lots of people are saying it was great.
I have a comment for you, Hugo.
Okay.
Well, it's not actually for you. It's for Microsoft if they listen. For some years, when we had the Connect site, you remember that? I had the feature request for creating inline scalar user-defined functions, which I would have preferred to have much, much more than this complex, not working very well inlining of table or of scalar user-defined functions. So it can't be that hard to create another type of scalar user-defined function, which works the same as the inline table valued one, I assume, but apparently not.
I often, as an MVP, I often have been in situations where I have direct access to the developers and program managers on Microsoft. So both on and off the record, I have made the same suggestion that you had on Connect. I didn't know you had it there. I think, but that's my thinking. That's not breaking NDA because nobody ever told me, so I have no clue whether I'm correct or not. But I think the idea of Microsoft was, if we can get this inlining of scalar user-defined functions to work, we're giving the developers something better because they get better performance without any code changes. That thinking
if
in
they can get it to
itself
work.
is valid and correct if they can get it to work. It looked
Yeah.
like they got it to work. I was impressed when I started playing with the feature in the CTP versions of SQL Server 2019.
Mhm.
After release, I read about some bugs and I figured they will be squashed soon. And then 1 or 2 months later, the feature was disabled in Azure SQL Database, and that made me realize apparently the bugs are more serious and harder to squash than I thought.
Mm.
What they're going to do now, I don't know. I still
It's very
like the idea you have, and I have proposed myself to just give us inline table inline scalar functions. We'll do the code writing.
Yeah.
You can just inline them like we did with tables. But
Mm.
that's not my call to make. And
No, and
still,
I
if they can get Freud, that's the official the code name for inline for scalar inlining. If they can get that to work, if they manage to fix the issues, that would be great. But they also have to fix the limitations, because there's not only some issues, there's also some limitations. Like for instance,
and
you
quite
can't
serious
use a
ones, I
where
remember.
clause in your user-defined function. Well, I don't know about you, but I sometimes write where clauses in my code.
Yeah, it happens. Yeah.
It happens. It is sometimes needed, and then suddenly we can't use it in for inlining anymore. I see that it's hard, so I understand that. And
So there is a question.
oh, good.
So the global temp table, if you needed to use one, would you make it unique by session so that there are no locking issues? I'm not sure if this has to do with what he was teaching, but
It
that is
doesn't
the
have
question.
to do
Yeah,
with the topic, but it's a good question.
yeah,
I fail to see the point. If I create a global temporary table and then make it unique by session so that I use it only within a single session,
yeah.
then why do I need to make a global
Global,
temporary
yeah.
table? Then why not simply use a temporary table?
Correct.
The use
Is it
case for a global temporary table is when you, for whatever reason, needs to create a temporary table in one session
Right.
and be able to access it from another session, or at least from another scope.
Yeah.
What if you call a stored procedure, you load the table and then you call the stored procedure and want it to have access to it? I think it's a poor use case, but
I've
maybe
done
then
that with normal temporary tables. You don't need to have a global temporary table for that.
okay.
You can do that with a normal temporary table, I think, or with a normal user table. But I think you can even do it with a temporary table. When you create a stored procedure, the tables that it uses do not need to exist.
So is there a use case that you've seen for global temp tables? I'm just curious.
Like I said, I have seen one use case, and that was a very weird edge case where I had an asynchronous process set up with service broker running, and there was one controller thread that received messages. They all had to have access to some temporary data. So there were multiple spits, and they were spun up dynamically, and they spun down dynamically when we're done, all triggered by service broker messaging. And they all had needed access to the same data. And I think I even changed that to a user table later, but that started as a global temporary table. I think that's the only case I've ever had for it. And even that,
So
I'm
someone
now
in the
starting to
chat
doubt whether
says
I made
that
the right choice.
someone else says index name collisions on temp tables.
Sorry, what index name? If you create temp tables, don't name your indexes. Period. I've learned that the hard way, because I've run into the same thing, thinking, hey, I'm going to name my indexes. That's the best practice. Yeah, not on a temporary table.
The problem is if you have to use query store and force a plan, then it will not, the plan forcing will fail if you don't name it. It will say index not found for the next one.
Good one. I recently, in a completely different session, had someone mention the same thing, and yeah, that is a limitation. But unfortunately, if you name indexes in a temporary table, they will not be made unique. The table name itself will be made unique by appending some weird generated data internally.
Mhm.
The index name will not be. So if another user on their own SPID uses the same code, they will get a violation.
Oh, okay. That's
And
interesting. That's something
I
I have
also
to
don't
do.
see
Yeah.
a solution, because
Yeah.
sure, we can tell Microsoft, hey, if I create a temporary table and say index name ix_abc, then you need to append something to make it unique.
Mhm.
Then we don't get this error anymore.
Mhm.
But we run straight back into the same problem that forcing with query store won't work, because the index name is different every time.
Right.
The forcing only works if the index name is predictable and always the same. And if you have multiple copies of the index of the temporary table with the same index name, that's going to be an issue.
Mm.
So if Microsoft figures out a way to fix that, that will be a bit harder than just making some simple changes. They have to work around some very firm, hard-coded methods and things.
Yeah.
Are there any other questions left? I see here myself. Will they auto-flash, or do I have to drop?
Can't see any further. Oh, there is one. Okay.
For global temporary tables, yes.
Will they auto flush, or do I have to drop?
For global
So
temporary
same
tables,
person is asking about global temp tables, I guess.
yeah, I would definitely recommend dropping. Officially, according to the documentation, they should be automatically dropped when every session that ever referenced them is stopped. But I'm not sure I would dare to rely on that. So I would prefer dropping them, personally.
How did we end up discussing only global temporary tables after our session?
I have
Somebody brought up a question.
idea, but that was a question, and yeah, I answered it.